Okay, this lesson is review on area and composite area of figures. So you want to take these notes and you want to make sure you have your appropriate heading, which of course is your first and last name, the date that you are taking these, and your period number. You also want to make sure that you have the appropriate title, which is area and composite area review. All right, so simple area is the measure of two-dimensional space. The area formulas you're going to need are the area formulas are the area of a rectangle, parallelogram, or square is base times height, or you can also write that as length times width. It is a two-dimensional measurement where for any of these figures, for the rectangle, base times height, or you could call this length times width. For a parallelogram, your base is here. The height is from the tallest point perpendicular to either the base or the ground horizon. This is your height. So either of these could be your height, or again, you could call this the width or the length, but height really makes more sense here. And of course your square, all your sides are equal, so your base equals your height, your length equals your width, etc. So again, the area of a quadrilateral that is not a trapezoid is base times height, or length times width. Then you have your trapezoid. And the trapezoid, of course, looks like this. And the formula for a trapezoid is a little long, and you can actually figure out the area of a trapezoid without using the formula, but I'm going to give you the formula anyway. I want to make sure I give it to you correctly. Should have looked this up beforehand. Super awesome. All right, so let me look this up this way. Here it is. Oh, it doesn't give you area of a parallelogram here. Trapezoid. $248 and $278. Okay, so here we go. The area of a trapezoid, if this is base 1 and this is base 2, and this of course is your height. The height is always perpendicular to the base, or the bases. Your area of a trapezoid, area, A for area, and then I draw the area I'm referencing, the shape, is half of means multiply, the height, half of the height times the sum of both bases. And so the area of a trapezoid is half of the height times the sum of both bases. Okay, And the last formula that we need is the triangle. A triangle is half of a quadrilateral. So a triangle is half of a quadrilateral. No matter what triangle you draw, it's half of a certain quadrilateral. Therefore, the area formula for a triangle is simply the area formula for a quadrilateral, base times height, and then you take half of it. So you either multiply by half or divide by 2. It's very important that the height for a triangle is treated just like the height of the other figures, and it's the height perpendicular to the base. That means if you have a triangle, let's say that looks like this, if this is your base, your height goes from the highest point perpendicular to the base. So you would use this number for the base and this number for the height. Now, composite figures is where you take a figure that is made up of more than one shape and you cut it into shapes that you can deal with. So here I see a quadrilateral and a triangle. So if I were given measurements for that, I would use them to find the area of the separate pieces and then add them together for the composite area. So let's say I have some figure like this, and then I'm given certain measurements around here. Well, I can break my piece into however many shapes I want, as long as I have the prerequisite or necessary measurements. Or let's say I want to know, let's say there's a pattern here and there's a triangle in the middle, and I know that the height and I know the base of the triangle as well as the base of the parallelogram. Well, if I want to know, let's say I only want to know the area of the parallelogram that's not the triangle, well, that's when I would subtract. I would take my area of the parallelogram, I would subtract the area of the triangle.
Kim Gillis, please come to the front of the school. Kim Gillis, please come to the front of the school.
Then I would take that would be the composite area. So for example, let's say I have a figure that looks like this. Okay, that's my figure. And I know that this is 4, this is 3, this is 6, and this is 5. Okay. I also know that the entire length or height is 8. So this 4 just goes from here to here, but the 8 is all the way from the top to the bottom. I need to break that into shapes that I can work with and then add them together. Well, how many shapes do I see? I see a triangle at the top, and I know that the triangle, I need a base number. Well, from here to here, this is 3 and this is 5, so the base here is 8. And I know from here to here is 8, and from here to here is 6. So the total, 8 minus 6, leaves me with 2 for my height. Then I have this rectangle. I know the rectangle is 4 here, and it goes all the way across, so it's the same as the triangle's base. And then I'm left with this piece right here. Well, I know this part is 3. I know this part is 4 and this part is 6, so this leftover part is going to be 6 minus 4, which gives me 2. Now I'm going to find the area of all 3 of my pieces and add them together for the composite surface, for composite area. Well, for my triangle, the area of my triangle is half the base times the height. Here, that's half, the base is 8, and the height is 2. Well, 8 times 2 is 16, and half of 16 is 8. The area of the rectangle is the base times the height, which here is 8 times 4. 8 times 4 is 32. And the area of my small square, or small rectangle, is also base times height, but here it's 3 times 2. 3 times 2 is 6. Now I have all 3 numbers. I'm going to add them together, 8, 32, and 6. Well, 8 and 2 is 10, so 10 plus 30 is 40, so this is 46 square units. I didn't give you actual units. The only thing you want to be really careful of is if you are given, say you're given an example that includes a semicircle. And this was something that a lot of you struggled with. I want the area of that figure. Well, I'm going to break it into 2 pieces, a semicircle and a rectangle. Now let's say I know that this is 10, and from here to here is 10. Well, that tells me that my rectangle is a 10 by 10, and it tells me that my diameter of my semicircle is 10. But to find the area of my semicircle, I need the area, I need half of the area of a full circle, because semi means half. Well, the area of a full circle, oops, I'm going to write that on another line. The area of a full circle, as you know from the last review, is pi times the radius squared. Well, I don't have the radius here, I have the diameter. So I have the diameter as 10, which means 10 is equal to 2 times the radius. So I'm going to divide both sides by 2, and I get my radius equals 5. Now I can put in my formula, half times the area of a circle, which is pi r squared. So half times pi times 5 times 5, which is half times pi times 25. And I'm going to continue it on the next line. That's equal to half times 3.14 times 25, which is equal to half times 78.5, which equals 39.25. This is the area of my semicircle because I did half the area of the circle. So this is the area of my semicircle. Now I need the area of my square. It's a square because both sides are the same. I know it's base times height. I'm going to write my formula first. And here, base times height, they are the same measurement. So the area of my square is 100. Now I'm going to add the totals. 39.25 plus 100. I bring my decimal straight down, and I get 139.25 square units. Other than that, this just takes a lot of practice dividing up the pictures into triangles, rectangles, and semicircles. That's all you have to do. Those are the three things you're going to work with, are triangles, rectangles, and semicircles. It just takes practice and a little bit of time to figure out how to break them up. Now you should do the alternative lesson, all the alternative lessons and the practices, check your work, correct your practice if it's incorrect, and then when you're ready, ask to take the quiz.